What do you think is the most important discovery of the past few centuries? The phone, TV, or computer? There's one chemical reaction you might owe your life to. I would argue this is it. 2 nitrogen gas molecules and 3 hydrogen gas molecules react to form 2 ammonia gas molecules. This is the Haber-Bosch process, and it enabled the mass production of nitrogen fertilizers, which helped our farms produce more than ever before. Without the ammonia from this process, farmers would be able to produce enough food for half the Earth's population, leaving the rest starving. It has been so influential to humans that 1/2 the nitrogen in our bodies is synthetic. Thanks to the Industrial Revolution, population growth rates increased. But it was hard to grow enough food. Harvest intervals are varied, and it could take months to renew for the next planting. It became clear to scientists that nitrogen was vital for growing crops. Naturally, when matter decays, it returns nitrogen to the soil, but agriculture disrupts that cycle. If you use the same soil to grow crops year after year, nitrogen is drawn out of it, and eventually, there'll be none left to yield a healthy crop. So farmers began using manure and compost which contain nitrogen, but it wasn't enough. By the mid-1800s, superpowers of the time went to great lengths to get better fertilizer. Hundreds of European ships traveled to islands off the coast of Peru to collect bird excrement. Guano is 20% nitrogen and holds ammonia, which is a nitrogen-containing molecule. Tons of the stuff were mined and shipped across the Atlantic. It was then used as fertilizer. In 1909, German physical chemist Fritz Haber managed something that had eluded scientists for decades. He synthesized ammonia from nitrogen gas. Here's the frustrating part. Even though 78% of air is nitrogen turning it into useful ammonia, fertilizer is extremely difficult. Nitrogen doesn't exist as a single atom. It exists as a molecule with 2 atoms held together with triple bonds, the strongest found naturally. It's extremely difficult to break. There are only 2 very rare natural processes that do this, either by lighting in the atmosphere or bacteria slowly eating away at rotting vegetation in the earth. Haber initially attempted to mimic a thunderstorm to make nitric acid, but he only got minute quantities, so he began experimenting with high temperature and high pressure. Haber spent 6 years developing a plan to combine nitrogen and hydrogen by passing it over an iron catalyst. He needed new equipment for this and was lucky to have access to hard-to-find materials, including osmium, while working at a light bulb company. This allowed him to obtain everything he needed to create a new apparatus which could handle the extreme conditions. In March of 1909, Haber placed osmium foil in the pressure chamber and heated and pressurized the nitrogen gas and hydrogen gas to 200 to 400 atmospheres and 400 to 650 degrees Celsius. Under these conditions, the triple bonds broke and the nitrogen reacted with hydrogen. 6% of the total mixed gas turned into ammonia. When the gas cooled, liquid ammonia formed. Germany's largest chemical company, BASF, had engineer Karl Bosch help Haber turn it from a lab experiment into a commercial process. The team worked in a concrete chamber away from other workers due to frequent explosions. When completed, the Haber-Bosch machine produced 5 tons of ammonia per day. This is a modern-day apparatus. The liquid ammonia is produced in 5 major steps. 1. Gases are fed into the apparatus. 2. They are preheated and passed over a heated catalyst. 3. They are pumped to the next chamber. 4. Finally, they are cooled and the liquid ammonia is collected as the final product. 5. Any unreacted nitrogen or hydrogen is recycled. Since natural gas is a major source of the hydrogen gas needed for the reaction, it often occurs in big industrial facilities that are in regions with easy access to natural gas. The Haber-Bosch process produces ammonia for synthetic fertilizers that increase crop growth when injected into soil. This allowed farmers to increase food production 4-fold on the same piece of land. As impressive as the Haber-Bosch process is, it wasn't all sunshine and rainbows. By 1914, the world was at war. Ammonium nitrate, apart from being a great fertilizer, is also an explosive. Germany was struggling to make explosives. Haber, being a patriot, wanted to help his country. He began producing ammonium nitrate by using the ammonia from his own process. Ammonium nitrate explosions are so dangerous because the triple bond in nitrogen molecule takes a lot of energy to break. But when two nitrogen atoms come together and form that triple bond, a huge amount of energy is released. It is from this triple bond that chemicals develop their explosive energy. The Haber-Bosch process has seen several advancements, such as the adoption of less expensive iron-based catalysts like magnetite. Nowadays, catalysts are in the form of mesh or pellets, which have a larger surface area and provide higher ammonia yields. Haber initially used osmium foil as the catalyst. That has been substituted, making the materials easier to transport and handle. Over time, the understanding of the Haber-Bosch process and its underlying chemistry has undergone significant changes, leading to new developments and changes in ideas surrounding the reaction. At first, the process was seen as a revolutionary discovery. At the time, the reaction mechanism was not fully understood and was seen as a way to make fertilizer to satisfy increasing global population. In upcoming years, research into the mechanism of the Haber-Bosch process caused a deeper understanding of its underlying chemistry. This led to the development of new catalysts, such as iron oxide, which were cheaper and safer to handle than the original catalyst, osmium. These developments meant greater efficiency in ammonia production, making it more cost-effective. As the environmental impact of the Haber-Bosch process became clearer, there was a growing recognition of the need to shift towards more sustainable farming practices, such as using nitrogen-fixing crops and reducing reliance on chemical fertilizers. Ultimately, Haber won a Nobel Prize for synthesizing ammonia. The human population exploded from 1.6 billion in 1900 to 8 billion today. Billions more animals were farmed to meet human consumption. As the population grows, the Haber-Bosch process causes more nitrogen pollution, harming water systems. The process burns 3% of global natural gas. A shift to sustainable food production methods and less meat consumption may help mitigate these environmental impacts. With almost every meal that we eat, we benefit from the Haber-Bosch process, providing the world with convenient access to nitrogen.